Hello students, today we will go to chapter 11.2B Solving probability problems using set concept. Let's start. Okay, here we introduce a notation, or actually you may learn it in S3 already. This is the probability of an event E to occur. Okay, that means if this number is bigger than the chance of E to be occur is bigger. Okay, it is actually equal to the number of possible outcomes. It means how many outcomes will satisfy your event E, and over the total possible outcomes. Okay, and we just learned the set notation. If we use the set notation, it means the number of elements in E over the number of elements in S. S means the sample space, and it contains all the possible outcomes. Let's use the following example to illustrate. Toss a coin 3 times. What is the probability of getting a head and 2 tails? Okay, so first of all, if we want to solve this, we need to find these 2 numbers. So let's get it. Okay, what is the sample space? Sample space means all the possible outcomes, right? The elements. So if we use H to represent head and T to represent tail, then we get the following. Okay, so 3 heads, and we get the first 2 are heads, and then the last is tail. Okay, and then here I will give you all the possible permutation or arrangement. Okay. So here, you'll find that in total, we get the number of elements in S is 8. Okay, and then what is the event? The event means those elements in S which satisfy our concern. It means it satisfies 1 head and 2 tails. Then you just search in the sample space, right? So 1 head, 2 tail, we get this is the first one. 1 head, 2 tail, and this is the second one, and this is the last one. So it's the sample space, and not the sample space, the event. Then we'll get these 3 elements. So we get number of elements in E is 3. Okay, so if you get these 2 numbers, you will easily get the answer. So the probability of getting 1 head, 2 tails will be 3 and 8 here, right? So 3 over 8. Okay, I will give you 2 more examples later. Okay, but here I would like to introduce what means impossible event and certain events. Impossible event means the event contains no elements under our concern. Okay, for example, now here, if we use this example, the sample space is this, right? Okay, if we concern an event E like getting 4 heads, then it must be impossible, right? So you can imagine if that is impossible event, so there will be no elements in the event E under our concern. Okay, so the number of elements must be 0. So if the number of elements is 0, then you will get the probability is 0. Okay, if it is a certain event means it actually contains all possible outcomes. It contains all possible outcomes. So it contains all possible outcomes, that actually you can refer to it will be equal to S. Okay, it will be equal to S. So if the E is equal to S, then you will refer to the formula the numerator NE and this will be the same, right? So finally you will get 1. It means it must happen. It must happen. For example, if you in this example you toss a coin 3 times. Okay, the probability of getting 3 heads or tails. Okay, so then because you toss 3 coins, right? So this must be a certain event. You must get 3, no matter what, whether they are heads or tails, right? So that is the certain event means. Okay, so you can imagine these two are extreme case, right? Impossible event and certain event are extreme case, and the other must between them. Okay, so here I don't give you a very difficult or complicated proof. So the final you will get all the probability must be between 0 and 1. Okay, so just bear in mind. Okay, this one. So now we go to some example. Now a letter is selected at random from the word monster. Suppose A is an event of selecting a vowel. Use set notation to represent event A. So let's start. So we first find the vowel. Okay, A, E, I, U, right? So O and E. Okay, then the set will contain these 2 elements, right? So O and E. Then the number of elements in A will be 2. And B, the probability of that letter selected is a vowel. Okay, so P will be equals to the number of element in A over the number of elements in the sample space. So what is the sample space? The sample space means here, right? So if you select a letter, then you will get this. Okay, you can get a letter from this 7, right? Then sure, you will know this is 7, right? So this is actually the concept behind. Okay, so you get 2 over 7 finally. Okay, in real practice, we don't need to write. Okay, it's so complicated. It's write the number of elements in A, a number of elements in S. But now, when you learn the concept, okay, so we just try to practice. Okay, thinking in this way. Okay, it also helps you to understand and let's try to explore more in the other sections. Okay, so now let's go to this example. Okay, fast A, fast B. Each contain a red rose, a white rose, and a pink rose. Means, you get a vase A. There are 3 rows in vase A, and there are also 3 rows in vase B. So now, if a rose is taken at random from each of the vases, then find the probability that the 2 roses taken are of the same color. So let's use the set concept to try to find the probability. A part. So now let's get the sample space first. Sample space. So sample space, now we are taking a row from each vase, so we will actually get 2 outcomes from these 2 A and B, right? So for example, if both are red, then we use red to represent. The first one, here we use, this is from A and this is from B. So and then instead of R, we also can have red and white and also red and pink. Then these 3 cases are all getting red from A, but you can also get red from B but not red from A, right? So we also consider other cases. So you get WR, and WW, WP, and also PR, PW, and PP. PP. So actually you get 9 elements in the sample space. Now we are considering how many of them are of the same color. So, okay, the event will be same color means RR, WW, and PP. So we get RR, WW, and PP. Then we can get the answer, right? Same color. So the number of outcomes favorable to the event E will be 3, and here will be 9. So we get 1/3. Okay, then how about part B? Of different colors. Okay, you just use what we have written down in part A, then we can get the answer directly. P, different color. Okay, you can imagine, okay, actually in the situation, 2 roses must be the same or different, right? So if there are 3 of the same color, actually you don't need to count how many of them are different color. You can just use total is 9, right? So 9 minus 3, so you get 6 of them are different. But sure, you can also count it again to make sure you are correct and no careless mistake is made. Okay, so we get 2/3 in this example. So now please do the quick practice. Okay, I will show you more the skills in doing the quick practice in another video. See you.